Okay, so let's look at problem 14. This is asking us to sketch the graph of y equals 3 times floor of 2x, right? So something that I would advise doing if you haven't is to go back and look at the video for 13, because that explains how to graph the floor of x. And I'm going to do this in like 3 acts. So if we think about this, floor of x, right? So if y is floor x, was just the step function, right? From 0 to 1, from 1 to 2, from 2 to 3, and then back down, right? Down to negative 1, negative 2, open, negative 3. So we saw that in the video on 13. So what is this 2 going to do? Well, the 2 is going to make my lines like jump weirder, right? So the 2 is going to mean instead of having to get all the way to 1, I can only get to a half, right? Because 0 to a half times 2 is 0 to 1. So this is now going to jump up. Oh, there we go. So this is a half. This is now at 1. And then we jump up again at 1.5. And then this one is now at 2. And likewise, we go backwards, right? So this is now going to be negative 1, so forth and so on. Okay, but remember, this jumps up to 1 here, this jumps up to 2 here, this jumps up to, right? So this is at 1, this is at 2, this is at 3, this one's negative 1, this is negative 2, right? So when I throw the 3, so this is going to be y is just floor 2x. So when I throw the 3 in there, I'm going to get y is 3 times the floor 2x. So it's basically going to be this drawing, but the y scale is going to change, right? So same idea, making my jump every half unit on the x-axis, right? So this is now happening at 1. This is now happening at 2, right? And then I go backwards. So this one's happening at negative 1, but the y values are now, this is 3, because it's 3 times the value, right? This one is going to be 6, this one is going to be 9. So this would be negative 3, this would be negative 6. So this thing is like elongating top to bottom. So that would give me the graph that I need there. So there you go. That, I believe, is problem 14.